All right, Britt. Yeah, we can get started. Aloha, everyone. My name is Kaneni Kea, and I am the moderator for this session titled Improving Stormwater Quality with Compost Filter Socks. Please use the Q&A tool during the session to ask any questions you may have. At the end of the presentation, we will have a few minutes for the speaker to answer your questions. So without further ado, I'd like to introduce our speaker for this session. Dr. Britt Faucette currently directs research, technical services, and regulatory approval programs for Filtrix International and the organics recycling and stormwater management industries. He earned his PhD from the Odom School of Ecology at the University of Georgia, where he researched soil water plant performances of various BMPs used in soil erosion and stormwater management applications. Britt serves on multiple technical committees with the American Society of Test Methods and the Board of Trustees for the U.S. Composting Council's Research and Education Foundation. In 2008, he was the recipient of the annual Clean Water Award presented by the U.S. Composting Council, and he has authored over 20 peer-reviewed scientific publications, over 100 popular press articles, and has developed 7 federal and nearly 50 state specifications on organic materials that are used in erosion and sediment controls today. With that, please help me in welcoming Dr. Britt Faucette. Good morning, Dr. Fossett.
Thank you, and thanks to all of you for tuning in to the to our presentation today and joining the conference. I know your time is precious, particularly this time of year with the end of the year and coming into the holidays. So I really sincerely appreciate your time in joining us and in joining me today for the presentation. I'm gonna momentarily turn off my video just for bandwidth issues, and I'll turn it back on at the end when we do the Q&A, and I hope that's okay with everybody. Of course, I'll be here. I always like to start with a slide kind of like this, and I'm guessing that really all of you have seen a slide similar to this in your professional lives, but it really does a nice job of kind of laying the foundation of what we're going to talk about today. And really what it's showing is as we change our land use patterns from natural systems like you see on the left to greater development and urbanization like you see moving to the right, what happens is we fundamentally alter or change the hydrologic cycle or the water cycle. And in so doing, what we do is we create more, not just more stormwater, which was really the original intent of the slide, and you can see that in the color coordination, but we also increase pollution or pollutant loading that is being transported to surface water bodies. And I've sort of typed that into the graphic that you could probably see here as well. And what that equates to is greater water quality impairment, really in every single case. So we don't have to look any further than what nature has done or is doing in order to minimize stormwater runoff and minimize or potentially eliminate stormwater pollution, and looking at natural systems to the left. And really, in large part, what a lot of us are trying to do with green infrastructure programs and low impact development programs is really reintroduce those back into the urban environment or preserve those systems as much as we can. Now, I realize that almost none of us work on a whole watershed scale, which is what the previous slide was, and almost all of us work on a site scale, which is where, as we make decisions in our daily professional lives, this is where we have the greatest impact, no matter what your profession is. This is where we do have impact and choices, and where we can fundamentally alter what happens on the site. There's a secondary reason why I'm also sharing this slide with you. If you look a little bit closer, the percentages you see here with the hydrology are very similar, very much the same as they are on a watershed scale. But the other reason why, or the final reason why I'm sharing this slide with you, is if you look at that arrow that's pointing down, 35% surface water detained or infiltrated. This is obviously one of the things that nature does to minimize stormwater runoff and pollution. It's also one of the things we look to learn how to do that ourselves in land development applications. But we know when water goes down through that organic matter and topsoil layer, it gets naturally filtered, what we'd call biofiltration. And really that's the idea or the concept behind the compost filter sock. Really, it's the idea of biomimicry or innovation inspired by nature. So we're taking what we have learned in nature, and now we don't have to have a potentially a large land area footprint to induce infiltration. We can actually now put that above ground in the flow path nearly anywhere we want on a site or in a watershed, and really put it in the places where we potentially need it the most, that are the most challenging, and put it in a wide variety of applications. And that's really kind of the basic concept and idea behind the compost filter sock. If you're relatively new to the idea or the concept, you may not know that actually there's quite a bit of peer-reviewed scientific research in the scientific literature on the performance of compost-based BMPs, including compost filter sock. And notably, a lot of these have appeared, have appeared in the Journal of Environmental Quality, the Journal of Soil and Water Conservation, and Water Environment Research. And I'm going to share some of that with you here today. Also to note, there's some relatively new technical publications on the environmental sustainability and performance and ecosystem service benefits that compost-based BMPs, and including compost filter socks, provide. These first two are sponsored by the U.S. Composting Council, but they're great books on the soil and water. The first one's a soil and water connection. It's a watershed manager's guide to utilizing organics on sites and in watershed. And the other is a compost and climate connection, which helps understand how you can reduce carbon footprint, mitigate the negative effects from climate change, as well as utilize organic materials to try to reach a carbon neutral or carbon negative footprint on your site. And then finally, this one's been around for a few years now, the Sustainable Site, which is a full design manual that helps you design with a wide variety of compost filter sock and compost-based BMP applications. It's really a full design manual, which goes into the specifics on where to use it, how to use it, where not to use it, how to install it, how to maintain it, any performance research behind it, and any engineering aspects behind it. It's a great tool if you're a designer. You also may not realize, if you're relatively new, that really just about every federal or national organization that has the ability to create a guidance document or specification for compost filter sock, and at least one jurisdictional agency in every single state has also done so, whether it's the state transportation department or the state Department of Environmental Protection or state environmental protection agency, depending on the state that you're in. But the US EPA's national menu of BMPs, the USDA, NRCS, the Army Corps of Engineers, the American Association of State Highway Transportation Officials was actually the first national organization to create a specification for compost filter sock. Most recently, the US Composting Council, and of course, many of our state agencies have. So let's talk a little more specific about the BMPs and really the compost itself. So here's a generic list of compost-based best management practices or stormwater management practices. On the left, these are construction activity stormwater management practices, otherwise known as erosion and sediment control. And on the right, you have post-construction stormwater management practices or LID practices. And every single one of these are generic terms for BMPs. Every single one of these uses compost either in whole or in part. I've highlighted the ones in red that utilize a certain type of compost media. And this is going to be a critical take-home message I'll talk more about in a moment. And some of the research I'm going to share with you relates to these ones in red. So they all use a compost filter sock or can use a compost filter sock as the chief application. Give you a kind of a visual representation of what some of these look like in the field, from perimeter control of sediment to check dam applications, inlet protection applications, filtering pollutants off of a roadway, combining vegetation into the system to better target post-construction stormwater pollutants, actually building them up in a pyramid configuration into a sediment trap design to handle much larger drainage areas as well, something we're seeing quite a bit now around the country. So let's talk about the media specifically for a moment. So really, when we talk about all of these applications, we're really talking about really one of two types of compost media. The one on the left is what we call filter media or biofiltration media. We're going to concentrate on that today. The other one is really an erosion control blanket media or a growing media type. And if you look at both of these, one of the first things you'll notice is neither one of these look like the type of compost that you're used to buying in a bagged product at your garden center or utilizing in a garden or a traditional agricultural application. And if that's what you're thinking right now, ding, 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 you are absolutely correct. In fact, I would go so far as to say that if you're using that type of compost, which I would consider a high quality compost for those applications, is a low quality compost for these applications, simply because of the particle size. There's actually a lot of research that evaluates this and bears this out. And you have to get the particle size correct, or you will not get good performance in the field. So what you're looking at here with the biofiltration media, you can see that it's a very coarse, large particle material, and that is critically important. It's specifically designed for optimum filtration of pollutants, as well as hydraulic or water flow, passive flow of water. We don't want to dam up the water. We don't want to create a solid barrier. That is the antithesis of what we're doing here. We're trying to create a passive biofilter, and you need those large particles to do that, and that's represented here. It is compost. It goes through the exact same controlled microbiological process that a typical high quality compost would. The only difference is that at the very end of the process, we use large industrial screeners to separate out particle sizes, and the small particles that we get into a bagged product are usually what come through that screen, and what we separate out in many cases is what you're looking at here. So let's talk a little bit more about the particle size for a minute, because this is, as I mentioned, this is a critical component to its performance. And if you don't utilize this type of material, it can really have a profound impact on performance. And in fact, we've done some research and testing that shows the diminished performance when you don't follow these specifications. So what you're looking at here, this is, if you look at the bottom, this is particle size in inches. And as you go from 1/4 inch to 2 inches in size, you're selecting for those. What happens is the flow through rate goes up, the filtration ability goes down. And really, and then when you go to the other end of the scale, as you select for more smaller particles, and you really get everything below 1/4 inch, which consequently is reflective of one of those bagged type product composts, which we're not using here, you can see what happens is that flow through rate goes down really to the point of nothing. It's really just blocking everything. Filtration ability goes up to the point where you're not really filtering either. You're just blocking everything. And so consequently, what happens in that scenario is you're just blocking everything. What happens is that you quickly will get to an overtopping situation. You don't get filtration anymore. You're just blocking. So you get overtopping. You have a higher propensity for undercutting or some sort of bypass. Water will find a way if you don't let it through. Consequently, this is what a straw wattle is designed to do, and a silt fence in many cases is designed to do. It's really designed to block and restrict flow in order to get sediment deposition from occurring. There's not a lot of filtration component going on here. Compost sock is a little bit different, and through the selection of these coarse materials, we sort of have this optimum performance zone. And you'll see this reflected in just about every state and federal or national specification as well. So let's talk a little bit. Let's continue on with the kind of the how of how the compost as a biofilter works. And this is one of the things that really makes it really unique, in my opinion, as well. So there's really 3 different ways that it really contributes to the filtration or biofiltration of stormwater runoff. The first one is actually not all that unique, and I've already been talking about it, and that is we're manipulating the particle sizes of the of the compost media, selecting for larger particles. And what that does is it creates a variety of pore spaces within the media matrix, allows water to move through. But what we do is now we're able to trap particulates and sediments, obviously other pollutants that are attached to those particulates or sediments. We would get those as well in that process. And anytime you put something in a flow path, you're also getting flow restriction as well. So you get, when you have flow restriction, you get some sediment deposition going on as well. So it really, by doing this, we're combining both sediment deposition and filtration at the same time. And we do that by manipulating the particle sizes on the inside or of the compost media inside the sock. Here's where it gets really unique, okay? And there's a chemical component, and I don't mean we're adding chemicals, but we know that composted material actually has a high affinity or high ability to sorb or adsorb soluble stormwater pollutants in stormwater runoff. And this is pretty unique to compost. So if you're familiar with activated carbon, it's the little carbon materials that we often use for drinking water filtration. There's probably some in your water filter at home right now or in your office. It's actually a very similar thing of how compost works. It doesn't work to the same degree or same level, but it's similar. So through the composting process, every particle of compost has a very high surface area per particle. And this only happens during that active composting process. And so through that very high surface area and the electromagnetic charges of the compost material, it's able to sorb or adsorb a variety of soluble stormwater pollutants that we find in our stormwater runoff. Key examples are ammonium, nitrogen, and a wide variety of metals. And the process there is very similar to what an activated carbon does, just not doesn't have the same level of surface area as that media does. What's also really unique is the biological component, and we know that a mature, well-composted material has both a high population density as well as diversity of beneficial bacteria that can degrade and transform some of the pollutants that we're trapping in the system itself. So we actually get a bit of bioremediation in situ or in the field going on in the system that we don't typically see in other types of BMPs or other types of medias because of this. And that comes from the compost and the composting process. There's a fourth component here that I have not typed in because it's more of an option, and that is phytoremediation. So we can select certain plant materials and blend in the seed to the compost media or plant directly into the sock a variety of different plant materials that have an affinity to take up some of these pollutants out of the compost filter sock up into their biomass, and thereby taking them out of the flow path and out of the filtration system, and thereby extending the longevity of the system as well. Phytoremediation. So let's share a little bit of the research. So this is a study that was done at the USDA Ag Research Service at their research headquarters outside of Washington, D.C. This is Beltsville, Maryland. It's been published in the Journal of Soil and Water Conservation. They looked at the comparing the performance of compost filter sock and silt fence for suspended solids reduction and turbidity. And you can see the differences between the two there and the performance of the compost filter sock. A somewhat similar study done at San Diego State University comparing compost filter sock to straw wattle using a ASTM method for designed for erosion control materials. Again, you can see the performance differences for each of the two BMPs there on the right. And then also, this is a study done at the University of Georgia, published also in the Journal of Soil and Water Conservation, looking at suspended solids reduction of sediment barriers on large-scale field test plots. This particular study, they looked at two different diameters or sizes of compost filter sock, and they compared it to other organic materials or BMPs that we often find being used on construction sites. Even in some cases, we see them used in a post-construction context, but mulch berms and straw bales. And two things came out of this study. One, the significant difference in performance of the compost filter sock compared to these other applications. but also we found not a significant difference in sediment removal efficiency between the two diameters. And in fact, we began to learn at this point, the only reason to go to a larger diameter compost filter sock is really when you're trying to handle larger drainage area, to handle more runoff or more sediment storage capacity, not necessarily to improve sediment removal efficiencies. Now, one of the things that's unique before I get into this slide is here I've shared with you three different research studies at different research institutions from different parts of the country using different sediment types, different runoff volumes, different concentrations and loads. And they all show a trend, which is, I think, pretty unique across these studies of about 80% removal efficiency of sediment for compost filter sock. And then we found it again in this study as well with the USDA Ag Research Service. In this particular study, they wanted to move beyond just looking at sediment and look at a variety of post-construction stormwater pollutants. And at this point, when this study was being conducted, we were seeing the compost filter sock being used more and more to target post-construction stormwater pollutants, not just for sediment anymore. And this is pretty critical to evaluate this and understand how it works in these applications for post-construction pollutants, because we know in the post-construction context, and this is, we've seen this a lot in the research literature now, that the total pollutant load in the post-construction stormwater context can be roughly 80%. The total pollutant load can be about 80% in the soluble form. So not attached to particulate, not sediment-bound pollutants. Obviously, the opposite of that is true in the construction activity context. Conventional wisdom says there's a high degree of sediment load. You target the sediment, any other pollutants that are present, they're likely going to be attaching themselves to sediment. So target the sediment, you're likely going to get the other stuff, the other pollutants. In the post-construction context, that is no longer true. So you really can't use traditional sediment control devices in that context. They really have to be able to target these soluble forms. And that's really what this study did and was able to prove out that the compost filtration media in the sock can target the soluble forms of these pollutants. The results have been published jointly in the Journal of Environmental Quality and Journal of Soil and Water Conservation. But you can see after the sediment species here of suspended solids and turbidity, these are all soluble form pollutants: total nitrogen, ammonium nitrogen, 60% removal of total phosphorus. They're able to remove 98% of total coliform bacteria, E. coli bacteria. They looked at a variety of metals that we often find in post-construction stormwater, copper, cadmium, chromium, nickel, lead, and zinc, between 37% and nearly 80% removal for those. And then also a high degree removal of petroleum hydrocarbons in the form of motor oil and diesel fuel. One of the things I've been most excited about recently is the relatively new development of a fully 100% natural biodegradable sock or system. So I can honestly tell you, before I came to my current role at Filtrex, I was in academia at the University of Georgia, and I worked in the engineering department there and worked in stormwater management and erosion and sediment control. And when I left there and I was given a presentation to a group of architects, landscape architects and engineers on compost filter socks, I gave the presentation, and the first question I got, this is many years ago, was, "Hey, cool technology. Do you have a biodegradable mesh that goes with it?" And of course, at that time, the answer was no. And so we've been working to develop this for quite some time, not just any old mesh, but really something that is both strong and durable and can last long enough, but also be 100% natural and biodegradable and completely go away in a responsible amount of time. And so that's what we've been able to do more recently. I'm really excited about it. It's one of the developments that I'm most excited about recently. And you can see, why a lot of folks are interested in having a completely natural biodegradable BMP on the job site, whether there's a wide variety of reasons to want that and to choose that. And depending on who you are or where you're working, it may be one of these reasons, it may be three of these reasons, or it may be all of these reasons. I encounter them all quite a bit, but really the reduction in petroleum-based products, elimination of microplastics in our waters, elimination of materials of any type going to a landfill, reduction of labor cost to remove products, materials at the end of a project. That's a pretty significant one. Obviously, having materials that are not going to entrap wildlife or entangle landscape equipment is a big deal for a lot of folks. And then also really just having materials and products that are compatible with the permanent and the natural landscape. You know, we're all working in erosion and sediment control and stormwater management. At the core, what we do is protecting and improving water quality. That's a big part of the environment. You know, why wouldn't we go the extra step to make sure that the materials that we're using don't also have a negative impact in some form or fashion on the environment? So I'm really excited about that development. And really, one of the things I've noticed over my time in working in this area is what seems to be attracting a lot of folks to the compost filter sock and other types of compost-based BMPs is the environmental sustainability of the application or the technology of the BMP. And I'm just finding more and more people galvanized by that and interested by it. And a lot of this probably goes without saying, you're probably familiar with it, but obviously the compost itself is obviously 100% recycled already. It's a biologically based organic material. It's almost always locally manufactured. It just doesn't make sense to transport compost over long distances, not only because it's heavy and that's expensive, but there are nearly 4,000 compost operations distributed across the United States. So chances are there is a compost operator or supplier near you that can meet these specifications. And really not only is that beneficial that we're utilizing these local materials, there's a sustainability story there, and that we're utilizing materials that are either native or adapted to the actual landscapes in which we're reapplying them, which is pretty critical. We're not shipping materials from another part of the globe or another part of the country where they are not native or not adapted to. But that also has a pretty big impact on reducing carbon footprint if you can utilize these local materials. That's not the only way that it reduces carbon footprint. Just by applying these materials back onto the ground or into the soil, the compost materials are generally 50% carbon, and much of that is what we call stable carbon. That happens in the composting process. If it's not composted, that does not occur. And that's calculated as a form of carbon sequestration, actually taking carbon out of the atmosphere, because that form of carbon is a stable form of carbon. But actually, the biggest way that you reduce carbon footprint is by diverting these materials from the landfill. So organic waste in our landfills is one of the leading sources of methane generation in the United States today and most developed countries. It's a greenhouse gas that is, depending on the piece of research literature that you look at, between 25 times and 100 times more concentrated in carbon as carbon dioxide is. It's what we would call, choose your number, 25 carbon dioxide equivalents. So it's a very potent, very concentrated greenhouse gas or carbon-based gas. And by preventing these organic materials from going into the landfill, you're preventing that from occurring. So simply just by choosing the materials, you prevent that from occurring. It's what we call methane avoidance. Other than that, as I mentioned earlier, we're utilizing natural principles to do a natural thing, to treat stormwater. It's really the idea of biomimicry. And it probably goes without saying, but if all this was true, but it didn't do a good job of protecting water quality, it probably wouldn't be a very environmentally sustainable practice. So it is a high performance sediment control and stormwater treatment system or treatment device. And so it has to be. I mean, that's the first and foremost reason why we're choosing and deploying these types of practices, but you get all the rest of it as well. So just kind of a quick summary of some of the advantages before we wrap up and have a moment for question and answer. And of course, a lot of this is just reviewing what we've talked about, but the material is natural and biodegradable. It can, and in many cases, probably should be left on site. It's great for soil quality and helps to eliminate really expensive removal and disposal costs. More recently now, the mesh itself is both natural and biodegradable, comes in a cotton and a wood fiber based material that will completely biodegrade over time. It has that rare combination of both high flow and high pollutant removal performance. This is a pretty unique aspect for BMPs in stormwater management or sediment control applications. It's one of the few BMPs that doesn't need to be trenched into the soil or require the labor-intensive and material-intensive rope lash over method, which is rope lash over method, which is still utilized in some of the Western states. It can just be, as long as the ground is prepped, it's not bumpy or rocky, you can put the product directly onto the soil surface without an issue. It really decreases installation time and effort and labor costs. It's extremely versatile. It comes in a wide variety of sizes or diameters, 5-inch, 8-inch, 12, 18, 24-inch diameter. And not only because of that, but it is in part because of that, it can be used in a wide variety of applications. Perimeter control of sediment, slope interruption device, check dam applications, inlet protection, stockpile protection, building it up as a sediment trap by the pyramid configuration, which I mentioned earlier, as well as post-construction stormwater treatment. So with that, appreciate your time, and I think we probably have a little bit of time for question and answer. Thank you.
Awesome. Thank you, Dr. Faucette. Yeah, we have some time for questions and answers. So if anyone has any questions, you can type them in the Q&A section at this time. Dr. Faucette, we actually have our first question, and it's, since compost biosock has the ability to absorb chemicals, does disposal get treated differently after use?
That's an excellent question. And the answer is, it depends. It depends on what the pollutant is or the pollutants are. So if the pollutants are obviously sediment or nutrients, even potentially bacteria, which can be quickly killed by UV exposure, nutrients can be taken up by plants. These are examples of things that you can still spread into the landscape. Wouldn't put it directly into a water body or right next to a water body, but you can still incorporate those into the soil and vegetation. Metals, and hydrocarbons, gets a little more complicated. It kind of depends on what the metals are in hydrocarbons and to what concentration. Now, we know that when in a bioretention system and a rain garden system, they're also targeting all of these same pollutants, and we're leaving those systems in place. We're not removing that media. It's really targeting those pollutants over time, and they're being adsorbed both to the media and plants are taking them up, and that's the same concept happening here. However, I will say, if you're getting a lot of some more toxic type pollutants, I would definitely take those to a landfill as well. You don't want those to build up too much and then have a breakthrough. And that's kind of one of the easy things about a compost filter sock relative to other things is it can be easy to remove and then dispose of if you need to, depending on the pollutant of concern. It's a good question.
Awesome. We have a couple more questions. What is the typical life expectancy of all organic filter socks?
Another good question, and kind of depends also. It really depends on how you're using it and what you're targeting. So, and honestly, that mesh containment system too. So, in a general sense, if you're utilizing the polypropylene mesh, which is intended to last a long time, the system can last for a couple of years for sediment control. You'll just want to make sure that you're maintaining it appropriately, like you would any other type of sediment control device. You're removing the sediment when it reaches half of the height of the device, and you're doing a good job of maintenance. It'll last quite a while. If you're using the biodegradable material, it depends on the amount of moisture and warm weather you get, but those are designed to last between, I'll say really up to 18 months. but can degrade faster depending on your environment. And then depending on the pollutant. So if you're using it in a post-construction context, again, similar to what the previous question, presumably in some of those applications, you're actually doing some testing on site for compliance, whether it's an MS4 or an industrial stormwater permit. And you'll want to watch your effluent limit guidelines for that site and where the concentrations are in your testing, where you can remove that when the time is right to put in a new filter or a new cartridge, if you want to call it that, for those types of applications. So again, in summary, it kind of depends on the application, the pollutant, and the environment that you're working in. It's a good question.
Awesome. Another question, how long does the biodegradable mesh Biosock last before it fades away?
Yeah, I addressed that in the previous question, but again, depends on the environment. So the things that contribute to its biodegradation or its speed of biodegradation are going to be temperature and moisture for the most part. So those conditions that are most moist and warmest are going to lead to biodegradation of that mesh faster. So anywhere generally between 6 months and 18 months is sort of the range there. Good question.
How do we know if the compost sock specified has the correct particle size?
Excellent question. You should ask that question of anybody in the chain of using it, whether it's the specifier, / designer, engineer, the contractor, the inspector, purchaser. Anybody should be asking for proof that that compost media in that sock meets specifications, including particle size. You can get that by a simple lab report analysis on the media itself, but it should be more than just the particle size. It should also be pH of the media. It should be inert materials that may be associated with it, but that's an critical question to ask and make sure that you receive if you're a part of that process. It's a good question.
Where is the compost filter sock media sourced from?
Good question. It depends on where you are. So, I'll just speak, personally, and for you guys know that I represent Filtrex. So we work all over North America and a handful of other countries. So what we do, we're not in the composting business. We don't make compost. What we do is we partner with local suppliers to ensure that they can actually, who first make compost, but two, make sure they can make it to meet the specification. Not all composters, while they may be a great composter, can or are willing to meet the specification for compost filter socks. So we work individually with each one of them to make sure that they can, and continue to do on a regular basis through testing and our partnership. So it depends on the location and state that you're in, but we have compost partners all over North America.
Sounds good. Once finished with the project, can the Biosocks be cut open and used as ground cover?
Yeah, excellent. Yes. The preferred answer is yes, and we talked a little bit about this in the presentation, but you're reducing or eliminating the cost to remove it and dispose of it into a landfill. That's a labor cost, and that's a cost to take something to the landfill. So if you can cut it open and spread it, you're saving a lot on a life cycle cost. It's also really good. Compost is great for soil quality, and it's good for the environment. So if you have the ability to do that, you should. Now, in some cases, you may be in an ultra urban environment, and you may have a hard time finding where that should be. And I get that. So it's not going to be you're not going to have that opportunity in 100% of the cases. But if you have the ability to do that, you should, for sure. Good question.
Awesome. A couple more questions before we end the session. Do the petrochemical absorption properties diminish over time? When do you know it is no longer working?
Good question. Does it diminish over time? There's a couple components to that. So in a general sense, no. There's nothing about the media itself even as it may change slowly over time. One thing I should say is one of the things that happens in the composting process, which you don't get with a wood chip or just a mulch or any other material, is that organic material becomes very, very stable. So while everything is breaking down in the environment, and that's true for everything, shingles on your roof, everything, that's also true of the compost material. But because it's been composted, that breakdown is now very, very slow. It's very quite stable material. Now, that said, it still does occur, but there's nothing in that process that diminishes its ability or capability to target and remove petroleum hydrocarbons. What would diminish it is if it continues to, if it's getting a high exposure of hydrocarbons, meaning there's a high concentration or high loading rate of hydrocarbons in the drainage area. And just like any filter, if it's working well, it's working and it's working and it's trapping and it's trapping. And then at some point, you're going to get near capacity. And how do you know when that occurs? You may actually see some of that because of the viscous nature of petroleum hydrocarbons. But in a lot of these cases, folks are actually testing as well. So they know that hydrocarbons are an issue on their site. Maybe they're just testing for oil and grease as part of their stormwater permit. And they're going to realize, okay, we're starting to get some breakthrough through the compost filter sock. Time to get a new one because it's not performing as it once did on day one. So yeah, good question.
Awesome, Britt. I think this question kind of ties into the one that you just answered, but how can compost filter socks prevent petroleum runoff from highways when it allows water to normally flow?
That's good. That's a good question. So and it really has everything to do with the organic material itself. So the organic material, while it will absorb some moisture, it's not like a sponge. So it'll absorb a little bit of water, and then water will passively move through the system. The organic matter actually has a strong affinity for petroleum hydrocarbons. Not only that, and we've seen this in a lot of organic types of material, but because hydrocarbons are generally viscous, and really the more viscous they are, motor oil is one of the more viscous, gasoline one of the least. That viscous material actually has a physical affinity also for the compost material. So just having that organic physical material there and the high surface area of that per particle of that media helps to create that affinity and high capacity to filter out the hydrocarbons. Good question.
Awesome. So we do have one more question. I'm going to forward that over to you, Dr. Fossett, just for time's sake. But if anyone else has any questions for Dr. Fossett, please find him in the conference. His contact information is also up on the screen. So yeah, that concludes this session, and the next session will begin at 10 a.m. Please return to the sessions tab to see the next breakout. And if you're experiencing any technical difficulties, please visit the info desk for assistance. And don't forget to stop by and check out the vendors during the break. Thank you, everyone.
Thank you.